So our power grid has this hidden pulse. We're going to dig into something called sub-synchronous oscillations.
You can think of the grid like it has a steady heartbeat. SSOs, they're an unexpected, unstable rhythm. In simple terms, they're just low-frequency vibrations that can mess with the grid's normal electrical flow.
This isn't exactly a new problem, but it's becoming a huge deal as our energy sources are changing.
Yep, we're shifting away from those huge, spinning generators to a grid run by wind and solar.
And this new grid brings new headaches. SSOs aren't just one thing, but a whole family of issues.
The two big ones you'll hear about are subsynchronous resonance, or SSR, and subsynchronous control interaction, or SSCI.
SSR is when the physical parts of a generator, like its massive spinning shaft, start vibrating with the grid. SSEI, on the other hand, is purely electrical. It's driven by the super-fast controls in modern renewables.
Right, this isn't just theory. When these oscillations get out of control, the results can be, well, pretty dramatic.
In fact, two major events in history showed engineers just how destructive these SSOs could be.
At the Mojave plant, the vibration was so intense it literally broke the massive generator shafts. Pretty wild.
Then in Texas, a different kind of SSO damaged both the grid equipment and the wind turbines themselves.
And look, this is now a global issue. As more renewables come online, the risk just keeps growing.
Just to give you an idea, one system in China spotted 58 of these events in a single year.
If you don't manage these, you're looking at broken equipment, power outages, and a really unstable grid.
Okay, so this is the big question, right? Why does this super technical stuff actually matter to you?
Well, it's because the same tech helping us decarbonize is also changing the fundamental physics of the grid.
The old grid got its stability from sheer physical mass. The new grid relies on lightning-fast software.
So the whole game for engineers now is tuning these controls perfectly to stop these oscillations from happening.
It leaves us with a critical question. As our grid gets greener and smarter, how do we keep it stable?